In the inductive process, inherently, there are four major problems. The first problem is that in the human condition, we are prone to commit mistakes. The second problem, in the human condition, we are prone to become illusioned. The third problem in the human condition is that we have the tendency to cheat and to be cheated by others. And in the human condition, the fourth problem is that we are limited by imperfect senses. So these four problems make the inductive process quite unreliable from the very outset. And really, when you start to research the inductive process, which all of our modern science is based upon, there are so many philosophers throughout current history that have discussed the inductive process and have found all the different problems with it. Although this is never really taught, as far as I know, in the school systems, the current modern school systems of the public schools, even the private schools, the university systems, the high schools. This is never really talked about, how the inductive process itself is fraught with not only the four defects that I mentioned in the human condition, but so many other philosophical defects. John Hume and other philosophers have in detail. They have discussed this process as a method of gaining knowledge, and it's easy to see once we start to research into the inductive system of gaining knowledge that it is fraught with difficulty, that it is fraught with many pitfalls, but yet our entire scientific system rests on this. So I'd like to go ahead now and I'd like to discuss what is the current cosmology, how this came about, so that we all have a good understanding of what is the current inductive process of cosmology that has been given to us, what are the possible reasons that this has been forced upon us, and then look at some alternatives of ancient wisdom systems a little bit later on. So as we know, the current cosmological situation, which I'm calling a creation mythology, which I think is even generous to call it a creation mythology, because it is actually more like a creation superstition in that there's no evidence supporting it. Anyway, we'll get into that as we go. So the current system is that they say that there was a big bang 13 to 20 billion years ago, and that from a point of basically nothingness, this point was infinitely small, it was infinitely dense, and I think that there's a misconception sometimes that there was some kind of chunk of matter, and this chunk of matter exploded by some kind of unnamed force, or it's even hard to describe what exactly they're talking about. But somehow the impetus was there for this chunk of matter to explode. But that's not actually the theory. The theory is that there was basically a point of nothingness. The point was infinitely small, which means that it had no existence in time or space, and that it was infinitely dense. In other words, everything that was within the creation was contained within a point of nothingness. Somehow or other, with no personal touch, this point of nothingness exploded into a big bang, and that everything, everything that we see around us has come into existence based on the explosion of a point of nothingness. So that in itself is quite amazing and quite unbelievable in one sense. And I think the immediate reaction, even for a child, would be, is what put the explosion into motion? What was there before the explosion? What was the explosion exploding into? So if we just think about it for a moment, right from the very outset, this is fraught with many difficulties. But I'll go ahead and give a little bit of the history of this theory. Now, one thing we have to understand is that this modern theory of the Big Bang is only about 100 years old. And before that, it was believed that the universe was in a static, steady state, and that everything that we could see within the cosmos was contained within the Milky Way galaxy. In other words, there was just one galaxy. Everything that we could see was within that galaxy. Then, of course, Mr. Einstein comes along with a theory of relativity. And it was basically a theory of gravity, and he believed that this would represent the whole universe. But because Einstein, on a metaphysical level, believed that the universe was in a steady state of existence, even though his equations showed that either the universe had to be expanding or contracting, it was the clear result of the physics of his different mathematical formulas. Because in a metaphysical sense, he did not want to believe that, even though he was the creator of this whole system of knowledge called the theory of relativity, which primarily deals with gravity and how gravity is something different than on the cosmic scale, is something different from what Newton talked about. It's more the curvature of time and space rather than an effect that objects are having on each other in a mechanical way. That he came up with the cosmological constant, which was a factor that was added in so that the theory or the equations would not show that the universe was expanding or neither contracting, because on a philosophical level he refused to believe that. Well, of course, other scientists took a look at this, one of the primary one being a man named Friedman, who was in Russia at the time. So now Russia was more of a closed system at this time because it was just after the Bolshevik Revolution in the 1920s. So his knowledge did not really come to the forefront until much later on, because there was no way for people to communicate with him, neither was there a way for him to get the knowledge out there. But he showed that clearly the equation showed that the universe is either expanding or contracting, that there was no need for this cosmological constant that Einstein had added, and that if we just go with the equations as it is, as they are, that it can only be one conclusion, is that the universe is in some type of state of flux. Either it's expanding or it's contracting. This was also about the same time, or a little bit later, a priest named Abbé Lemaitre, he discovered the same solution to the Einstein equations, and this was about 1927 in Belgium. Some English researchers and English scientists from Cambridge discovered his work and brought him to England, and it became very popular among the intellectual class, and his ideas became very prominent among the intelligentsia of the time in Cambridge and Oxford and all the different English universities. That Lemaitre and Friedman showed that the universe is in a state of flux, that it has to be expanding more. It can also be contracting, but everyone was leaning more towards the expansion idea. Then the supposed proof of all this came by Hubble, and this is one of the great so-called theories of the modern scientific movement, was that Hubble proved that every object in the sky has a redshift, and this redshift was taken to mean that the objects were moving away from us, just as when a train moves towards us, the sound waves are slightly compressed, and the pitch of the sound waves becomes higher. And then as the train moves past us and away from us, the sound waves, due to the train moving, become further from each other, and the pitch drops. So the redshift was basically that idea that objects in motion either compress or expand the frequencies, but this was in light. This was not in sound, but in light, that objects moving towards us, they would have a blue shift. In other words, the wavelengths of light would become compressed towards the lower end of the frequency scale because the object was moving towards us, so therefore the frequencies would be closer together, therefore there would be a blue shift. And if objects were moving away from us, they would be shifted more towards the lower end of the spectrum, or have red shifts. So when they applied this principle and looked at the sky, and other astronomers at the time were looking at this, that every object in the sky had a redshift. So in other words, every object in the sky is moving away from us, was what the theory was. And what they also noticed was that not only were they moving away from us, but the further an object was, based on its luminosity, that the idea was that the things that are less luminous are further away. everything that is further away is moving at a faster rate than the things that are close to us. So this was taken to be proof of the expanding universe theory, that there is actually nothing in the sky that is moving towards us. All the different luminaries and stars and galaxies and nebula, everything is moving away from us and each other. Now this was according to Hubble's theory with the redshifts, etc., and what they had been observing. So this was a big moment in science. They were taking this to mean that, okay, that we had the Einsteinian equations, that they're a type of proof, theoretically, of what should be going on. And now we have, in the inductive method, we started with some observations. We have these observations. We have these equations. Now we have an hypothesis that the Big Bang is there, that the universe is expanding. Now we have the redshifts. That's the experimental data that we needed. And ultimately, the theory of the Big Bang came into being. So this became the primary accepted dogma of the scientific community, that galaxies are moving away. The further they are, the faster they're moving. So as they went on with their observations, they started to notice that there were these objects called quasars, which had extremely large redshifts. That means that, according to the theory, they had to be the furthest things away from us in the universe, that the further away you are, the faster you're moving away, and that the higher your redshift would be. So the quasars had very large redshifts, which means they had to be very, very far away, according to the theory of the Big Bang, and to fit into their experimental data. But because they were bright, that meant they had to be so incredibly bright that to even be seen with in correlation with their redshift and what they thought that their distances were, that these objects had to be very incredibly bright and incredibly energetic. And it couldn't even really be expressed in scientific terms. It was more of a metaphysical terms that they were describing it in, because it so much blew away all their notions of the energy of galaxies and the light that they could be giving off, that with redshifts as high as the quasars were, they had to be extraordinarily energetic and bright objects, beyond anything that they had ever seen before. But then they started to notice that these quasars always seemed to be clustered around spiral galaxies. And this became a big problem, because the only explanation that they could give for this was that it was an optical illusion, that the quasars were on a line of sight behind the spiral galaxies, and it just appeared that they were somehow in connection with these galaxies, but actually they were very much further away. But statistically, it was an anomaly, because almost always the quasar was associated with a spiral galaxy, and the rest of the sky, where there were no spiral galaxies, had relatively few quasars. But the only thing they could do at this point to save their theory was to say, well, it's all an optical illusion, that the quasars are just on the same line of sight, and it only appears that they are involved with these spiral galaxies. Now, because otherwise there was no way to, this was something that was completely outside their theory, which they at this point were very much wed to, in that they had the Einsteinian equations that said the universe should be expanding, and they had the redshift data, which also supported the expansion theory. However, there came to be a problem in the whole thing with the quasars, and they tried to write it off as an optical illusion. However, certain researchers, such as Halton Arp, he started to show in various ways that actually the quasars were definitely linked with the spiral galaxies that they were near, and that they started to take photographs of this, and they were always connected by filaments coming from the main spiral galaxy, and that the statistical data that the quasars were always associated with these spiral galaxies, it was not reasonable that this was all just a coincidence and a line of sight anomaly. So researchers started to really take a look at this,